Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I am Arif and I welcome you all in today's session. Well, to access the notebook for today's session, you can access course page on my personal website arif.me. You can click the appropriate link under the lecture resource column over here to view the notebook in NB Viewer and run it online in Binder. The other way is to download the notebook from the course GitHub account, Arif PUCIT, and all the notebooks for this course are housed in the public data science repository over here. Well, this is the Jupyter Notebook dashboard running locally on my machine at port 8888, and here is the notebook for lecture number 3.24 of the third module, Python Programming for Data Scientists, for the course titled Tools and Techniques for Data Science. My dear students, today is our fourth session on data visualization with Matplotlib, which is of course an important tool used in exploratory data analysis. Okay, so my dear students, if you have not watched my previous three videos and are new to Matplotlib, I strongly recommend that you should watch those three videos first and then fall back to this fourth one. However, today for the initial few minutes, I will have a quick recap of the previous session. Then we will see and understand designing of the box plot, violin plot, and heatmap using Matplotlib. The last topic I will touch upon in Matplotlib is designing multiple subplots or axis objects within a figure using the subplots method of pyplot. Okay, so we have a lot to do today. Let's start playing. So first of all, a quick recap. These two images describe the anatomy of a Matplotlib figure object that can have one or more axis objects in which we actually display our data. My dear friends, every axis object can further have an x-axis and a y-axis. Then there are a lot of aesthetics that we can add in a figure object, like the title of the figure, a legend, a grid, the x and the y axis labels, their major and the minor texts, the spines, the lines and the markers describing the data which we can have in different colors, sizes and styles. Okay, so first of all, this is the first chart, the line chart that we designed and developed step by step. And this line chart displays the chemicals and medicine exports in million US dollars of a company, Lahore Chemical Industries, LCI, in the last 12 years from 2010 to 2021. My dear friends, we all know that a line chart displays information as a series of data points called markers connected by straight line segments. We can have different styles, sizes and colors of these markers of these lines. So this was what we did in the first session, I think. Okay, in the second session we designed a variety of bar charts and two of them are shown over here. My dear students, a bar chart is normally used to show a relationship between categorical variables, which in this case are the names of these 6 students, and numerical variables, which in this case are the marks of those students in the subject of English and mathematics. Well, this is a vertical bar chart, and over here this is a horizontal bar chart representing the same data. This horizontal bar chart is preferred if the count or the number of categorical variables is more than 7 to avoid any cluttering. And we practically have seen this in the second session of ours while plotting the popularity of programming languages from the Stack Overflow developer survey dataset. So in the third session, I think we talked about the histogram. And that is in the histogram we use the same Stack Overflow developer survey dataset. we designed this histogram whose bars are actually showing the frequency count of ages of all the respondents who filled the form of the Stack Overflow survey. Uh, on the left we have this histogram, and on the right this image is actually a, a bar chart. I have created them side by side because they are normally confusing to the students. Remember, a bar graph uses bars to compare the different categories of data, while a histogram uses bars to display the frequency of numerical data. In a bar graph, each data point is rendered as a separate bar. So these are separate bars, and the bars never touch each other. On the contrary, in case of a histogram, the data points are placed in appropriate bins, and the height of the bar of that particular bin represent the count of data points in that bin. So over here, in this histogram, there are 10 bins, and the highest bar of this bin is belongs to 20 and 30. So this means that the maximum respondents who filled this survey belongs to the age group from 20 to 30. Great. Let's move ahead. So this was the scatter chart. We designed it in our third session. In a scatter plot, the values of two variables are actually plotted as points on a two-dimensional grid. And additionally, you can also have a third variable to determine the size or the color of the data points. Well, this particular scatter chart has 11 data points, and each point represents a house that is plotted in this 2D grid. There are three values associated with each house in the dataset that we use to design this scatter chart. Number one is its distance from location X, and its distance from location Y, and number three is its price. So we have also added a color bar on the right of this scatter chart that maps the price of each house to a color. Moreover, more is the price of the house, the larger is the size of the corresponding marker. So from this scatter chart, we can easily infer that closer a house to the location X and Y, the more is its price. Great. So we also talked about the pie chart as well. The pie chart is the last type of chart that we discussed in detail in the previous sessions. A pie chart is similar to a bar chart, but instead of plotting a bar for each category, a pie chart displays the proportion to which each category contribute to the whole. Well, this particular pie chart shows the proportion of students in the four departments of Faculty of Computing and Information Technology, University of the Punjab, Lahore. And note the pie that corresponds to the data science department is having least number of students and is exploded out a little bit for emphasis sake. So this is what we did in last summer. Okay, just joking. So this was a quick recap of the types of charts that we discussed in our previous three sessions on data visualization. So if you have not installed Matplotlib, you can install it using pip. And right now I'm using the Matplotlib version 3.4.3. So the first chart we need to design today is the box plot. So before drawing a box plot, let me quickly tell you an important descriptive statistical concept, and that is a measure of spread. We will, of course, inshallah, study this in detail in our statistics and mathematics for data science module of this course. But for the time being, just remember that there are four measures of spread: range, IQR, variance, and standard deviation. My dear friends, just like median divides your dataset into two equal halves, this IQR or interquartile range divides your ranked order dataset into four equal parts. For example, if you consider this numeric dataset sorted in ascending order, you find out the median of this data set, which is Q2 over here. This is 29. Uh, then you find out the median of both the halves, the left halves and the right half from Q2. And this is Q1, which is 20, and this is Q3, which is 39. The interquartile range is actually Q3 minus Q1, which is the region between the 25th and the 75th percentile. Well, to measure the variability, statisticians prefer using the interquartile range, IQR, instead of full data range to avoid the effect of outliers in your data. Okay, so enough of statistics. My dear students, a box plot. This is a rough diagram of a box plot. We use the matplotlib method box plot to graphically depict groups of numerical data using these five number summary. The minimum, the maximum, the median or the second quartile, the Q1, this is the first quartile, and Q3, this is the third quartile. Okay, so let me first read a dataset to practically understand this concept. So this is a CSV file, boxplot.csv, available on my GitHub account. I've used the read CSV method of the pandas to read the data in this CSV in this data frame. So this CSV contains 50 rows and 11 columns. 50 different students' records are there. The columns of our interest in while designing this box plot are these three: the marks of the students in machine learning, the marks of the students in data science, and the marks of the students in the subject of big data. So let us compute the 5-number summary for these three columns. So let me compute the min for this data science column of this data frame, which is 42. Let me compute the max, which is 95, and let me compute the median, which is 70. My dear friends, you can always compute the quantiles, the Q1, Q2 and Q3, 25%, 50% and 75%. You can note that the Q2 is 70, which is the same as this median. So great, we can easily compute these things. Now we are ready to draw the box plot for the students' marks in these three subjects to visually, graphically represent these 5 numbers. So we can use the box plot method to do that. Let me straight away jump to the code and let's quickly walk through this code. So first of all, we need to import the pyplot module of matplotlib. You can do this using any of these two import statements. Both are equivalent. Over here, these two lines, as usual. The figure method of pyplot will return a figure object, while this add underscore subplot method, when called on this figure object, will return an axis object on which we are going to draw our data. Well, these 3 lines of code are actually creating 3 lists from the 3 columns of the data frame: machine learning, data science, and big data. The 3 lists of marks in the subjects of machine learning, data science, and big data will be stored inside these 3 variables. And over here we are using the box plot method to create our box plot. Well, I am passing the 3 list, the list of marks in machine learning, data science, and big data inside this list values, which I have passed to this X argument of box plot. I'm also setting the patch underscore artist to true. This argument actually create a filled box. I'm also passing a list of strings as labels, X labels, to the three box plots so that we can get the labels associated with each box plot. And finally, over here we are setting the title, the X label, and the Y label of the axis object to appropriate strings. And I'm setting the grid to true. Okay, let me run it. Great. So these are the three box plots for the three subjects marks of machine learning, data science, and big data. Note for the box plot of data science, you can note that the minimum marks are 42, roughly 42, I think. The maximum marks, this line shows the maximum marks, which are probably 95. Well, this orange line in the middle is the median, or Q2, which is exactly 70. Over here we have Q1, which is roughly, I think it is 57. And this Q2 is roughly 78. And these are the same calculations that we have done over here. Great. So this is what a box plot is. In the machine learning box plot, over here, these two marks, these two dots at 90 and probably 96, they are taken as outliers by Matplotlib. I hope this box plot is clear to you all. So let me move ahead and talk about another similar plot called the Violin plot. Well, my dear students, a Violin plot is very similar to box plot, except that they also show the probability density of the data at different values. So let me copy this code and show you how similar this Violin plot is with the box plot. So we just have to change this. Instead of box plot, let me write down Violin plot, and let me change this line as well from the string from box plot to Violin plot. So instead of box plot, we are using the Violin plot, and the only required argument to the Violin plot is the dataset, which equals to values. Let me just remove these from here for the time being. Fine. Let us run this. So we have got an error. So it says unexpected Violin plot. So we have Violin plot over here. Okay, fine. So these are the Violin plots. Great. So you see, we have three violins over here. You can see, if I assume that this is the Violin plot for the data science marks, the minimum line shows the marks are 42 and the maximum line shows marks are 95. Well, the additional information that these three violins are giving, other than the min and the maximum marks, are the distribution of the data, which was not available to us in case of the box plot. For example, in this Violin plot on the very left over here, I think this is of machine learning, very less number of students have scored over 60 marks. Very less number of students are there. And the majority of students have scored marks between probably 30 and 50, I think. So we do not see labels along the x-axis that should provide information as to which specific subjects these three violins belong to. So let us see what we can do in over here. Unfortunately, we do not have the labels argument to Violin plot method, which we have in box plot. So there is a solution to that, and that is we use the axis ax dot set underscore xticks, and we assign it a list of the number of labels that we want to have. So we want to have three labels, three xticks. Great. Similarly, ax dot set underscore x tick labels. And to this function I'm going to pass these three labels: machine learning, data science, and big data. So X labels. Great. So let me run this and see, do we have the three labels over here? So now we have the labels associated with each of the three violin plots. Well, my dear students, if other than the min and the max value, you also want to see the line representing the median or the mean, you can set the show median argument to this violin plot. Show, let's suppose DIANS is equal to, let me set it to true and let me run it. So we have the median line over here as well. Great. So what is left is the remaining two, that is the Q1 and Q3. So this is Q2. So what we do not see over here are the first quartile and the third quartile. So we can do that as well, and for that we need to pass an argument to this violin plot, and that is quantiles. And to this quantiles I need to pass a list of the two quantiles that I want to display. So let me name it quantiles, and let me pass it the list 0.25 and 0.75. So these are the two quantiles which I want to be displayed, but I want these to be displayed for the three violins. So I need to copy them 3 times. Great. So let me run it again now. So my dear friends, now these violin plots are exactly giving you the same information which these box plots were giving. Over here inside this box plot, you can see 3 box plots, and you can see the 5 numbers: min, max, the Q1, Q2, and Q3. And over here as well we have all the 5 numbers being displayed for all the 3 subjects. Moreover, we have the distribution of the data over here. Well, I think that is enough for box and violin plots. For anything that I have not covered, please check out the help page or visit the matplotlib documentation, whose link, of course, I have given at the top of the notebook. And move to the next plot, that is the heat map. Well, my dear friends, a heat map is a chart that is used to show the relationship between 2 variables. It is a graphical representation of a 2D data contained in a matrix where the values are represented as colors. Let us straight away jump to a sample code. Over here I am using the rand method of the random module of NP library, and I am creating a 2D numpy array having 100 random integer values from 0 to 255. Note that I have called the reshape method on this 1D numpy array of 100 elements to convert it to a 2D array having 10 rows and 10 columns. So let me run it. So this is our dataset on which we want to display our heat map. Great. So this IamShow method of pyplot is used to display data as an image. Its only required argument is x, to which we have passed the 2D array, this array, 10 rows and 10 columns. Well, over here I have also used the color bar. We have used this before as well in scatterplot. Let me straight away run this 2-3 lines of code and show you the heat map that we have generated. So this looks really great. So these are the 100 random values of this 10 by 10 matrix over here shown. So the values close to 255 are shown in white. For example, this value 248 is shown over here in yellow. You can see the color map. So the larger is the value, the lighter is the color, and the darker is the value. Of course, the lighter, the smaller is the value, the darker is the color. For example, over here we have this 60. You can note that this is probably that 60 value shown in black, closer to this. You can check out Matplotlib documentation for available color maps. We can pass an argument to this. Let's suppose see map, and let me pass it a value of gray. Let me run it again. So now it's more clear to you. Let me use another color map favorite of mine, that is cool warm. Let me run it. So this is really cool. Enough of heat map. Let's move ahead, my dear students. And the next topic is creating multiple plots within a figure. My dear students, a single matplotlib figure object, as we have seen in the very beginning in the recap, it may contain multiple subplots or multiple axis objects organized in a grid. Although so far we have worked on a single figure and the figure having a single axis object, but we can use this subplots method and we can pass it rows and columns to create a grid of subplots. Let me straight away move to the code and understand this practically. Over here, the code in this cell is calling subplots without any argument. And when called without any argument, it will return a tuple, a figure, and a single axis object. Let me run this. So we have a single figure, and this figure has a single axis object named AX. Great. And the two arguments that you can pass to this subplots method is the number of rows and the number of columns. If I pass one to these are the default values to this. So it will just create a single figure object having a single axis inside that figure. Okay. And over here, if you see, I am passing 2 to the rows and 1 to the columns. So it will create a figure having two axis objects, one over the other. The upper one will be AX1 and the lower one will be AX2. Let me run this. So this is AX1 and this is AX2 and this overall is of course figure. Let me run this now. The number of rows is 1 this time and the number of columns is 2. So this will create a figure object having two axis objects side by side. The left one is AX1 and the right one is AX2. Excuse me. And if you pass 2 rows and 2 columns, so you have a grid of 4 axis objects inside a single figure. This tuple AX1 and AX2, this is the first row. AX1, this is AX1 and this is AX2. Excuse me. And this tuple AX3, AX4, this corresponds to the second row. This is AX3 and this is AX4. Great. So one last example in which I have created a grid of subplots having 2 rows and 3 columns. So these are the 3 axis object in the first row. These are the 3 axis object in the second row. Let me run it. So remember, this is AX1, AX2, AX3, and in the second row we have AX4, AX5 and AX6. Okay, let's see a simple example. Let me first create a random 1D array. So this is a random 1D array of floats having 30 equally spaced values from -1 to +1. And over here I am creating a 4 axis objects, 4 subplots, 2 rows of each. These 2 axis objects AX1 and AX2 will be the first row, and these 2 axis objects AX3 and AX4 will be the second row. So in the axis 1 object or this subplot, I am just plotting x to x, which will be of course a straight line, and then I am plotting x with the x power 2, and then I am plotting x to x power 3, and finally I am plotting x to x power 4. Let me run it. So these are the 4 plots: AX1, AX2, AX3 and AX4. So these 4 subplots are there inside the single figure. Great. I hope this makes sense. And finally, let me show you the same uh, line plot from which we started our first session. The line plot that represents the Lahore chemical industries, showing the medicine as well as the chemical exports, the medicine as well as the chemical exports. But this time, instead of showing the two lines plots in a single figure and in a single axis object, we are creating over here two axis objects, one over the other, two rows and single column. The upper subplot is AX1 and the lower subplot will be AX2. The upper subplot AX1 will show the chemical exports of LCI, while the lower subplot AX2 will show the medicine exports of LCI. And over here, of course, we are just setting the title and the XY label of this subplot AX1, and over here I'm setting the title and XY label for AX2. Let me just run it and show it to you. So great. So this time we have one figure and two subplots or two axis objects. My dear students, I hope the concept of subplots in Matplotlib is clear to you all. Well, that is all for data visualization in Matplotlib. Our next session will probably the last session on data visualization, and inshallah, in the next session, I will give you a comprehensive overview of Seaborn library and how we can draw all these graphs that we have learned drawing in Matplotlib, how we can draw all these plots using the Seaborn. So this we will inshallah ta'ala done in our next session. Okay, so that is all for today's session. We will inshallah continue our journey to learn Python programming for data scientists in our next session. I hope today's session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. I wish you all the best, happy learning, and Allah Hafiz.